What is X-ray crystallography?
X-ray crystallography is a technique that you can use to characterize and so understand the structures of molecules when they're in the solid state. So as opposed to a gas or a liquid, when they're a solid, then X-ray crystallography is a way of working out how the molecules are put together in 3 dimensions.
I would say it is God's revealed truth. It is looking into the heart of matter using X-rays so that you can determine the 3-dimensional structure unambiguously of the material that you're looking at.
What does X-ray crystallography tell you?
X-ray crystallography can tell you about how the molecules put together, what atoms are attached to which other atoms, and also a lot of information about the geometry, so the angles between the bonds and the distances between the lengths of the bonds. So it gives you lots and lots and lots of information about, very detailed information about how the molecules are put together. The molecules are all packed, as we call it, into a very specific way. And the way that the molecules pack with each other can give you information about the chemical properties of the solid as well, and also help you to understand things like solubilities and things like that. So it's both information about how the molecule itself is put together, but also an indication of the way it interacts with other molecules. And so
I have a very nice, I think quite a nice analogy. So if you take light microscope, so in the light microscope you have an image that you want to look at, and you have a lens. And so what you do is you focus you put the object you want to look at under the lens, and the light gets focused, and you see an enlarged image. Now, in the case of X-ray diffraction, you can't focus X-rays. So what you do is you kind of perform the same experiment. You shine X-rays onto a material, but it can't be focused. So what you do is you collect the diffraction pattern, and having collected that diffraction pattern, you then imagine what the molecule might be like, and you then do a computer simulation where you calculate that diffraction pattern, and then you compare the two, the calculated pattern versus the real pattern.
Are there any disadvantages to X-ray crystallography?
I suppose the big disadvantage with crystallography is that you have to be able to have a sample of your solid that's crystalline. And so in the business we say we need to have a single crystal, which means that all of the molecules in the entire crystal pretty much are all lined up and packed in a regular way throughout. And that can often be very hard to achieve. There's all sorts of ways that you can go about trying to grow single crystals of your compound in terms of playing with different sorts of solvents, different temperatures, and all sorts of things. It's quite an art being able to grow good crystals. And so quite often that's the limiting factor. These days the machines are becoming so powerful that you can get data and work out the structure on very, very small crystals, but they still have to be single crystals by and large. And so that's the big trick.
You have to get crystals, and that's the hardest thing, growing crystals. It's a black art, and it still drives my students crazy trying to grow crystals. About 30% of all crystals are known now to be twinned, so you have 2 crystals growing intimately into each other, and so you get different diffraction patterns, and that's a real tough job to be able to sort out and solve the structure for a twin crystal. Sometimes the twinning is very minor, and sometimes it's very major, and that's been the problem. So the 2-dimensional detectors showed us that many of these crystals were twinned, and so you have this issue. 1, you have to grow crystals, and 2, you have to grow good quality crystals. My students say if they put down 100, we call them crystal jars, if you put down 100 crystal jars, about 10 will yield crystals that might give you X-ray data. So the hit rate's not very high.
What makes a good crystal?
Sharp edges and faces, that's the first thing, edges and faces. And it has to extinguish and polarize light. And, Polaroid glasses, let light go through them, and I think it's plain polarized light can pass through it. And if you take two lenses from a Polaroid glasses, if you break them, and if you put them like that, then no light passes through, so it goes black. And then when you turn them like that, the light can come through. So if you take a crystal and you put it in plain polarized light, and you twist and you turn it around, eventually the crystal acts like a little polarizer, and it'll stop light going through, and it goes dark. And then when you turn it again, it goes light. And so it's called extinguishing. And if you see that with a crystal, and it happens crisply and rapidly, you've got a good quality crystal.